I hope you guys are having a good weekend so far. So I know it's Saturday afternoon. I didn't get these put up earlier. I was a little busy. I'm gonna get the lessons done earlier this weekend, or by this weekend. I'll hopefully have all my lessons done for next week, and that way I can get these posted up as quickly as possible next week. So today we're gonna be going. So we worked on solving systems of equations. Now we're going to go into solving systems of linear systems of of inequalities. And really the easiest and the best way to solve inequalities, systems of inequalities, is by graphing. Okay, so let's look at number one. And actually, I'm hoping you guys got to catch the joke today. I usually try to put a little joke up here and use that to make the videos a little better. I apologize for the background noise. Kids are being a little whiny right now. Hopefully that'll be cut out from now on. So let's look at example number one. When you're doing these with the graphing, these are going to be just like linear equations. So the one thing you guys got to get used to is figuring out where the best place is to locate your x and your y axis. Not just always being given an x and y axis in a specific spot. So we're going to go ahead and put it in the middle, because with these, like I said, these equations are they're linear equations essentially, and with them being linear, that means that there's going to be positive and negative, which means I'm going to need to have all four quadrants visible, otherwise this will not work. So these are already in slope-intercept form, so you should know how to graph them. When we graph linear inequalities, you're graphing them just like you would a linear equation. So when you're graphing, when you actually graph the line, you're going to graph it just like as if it was y equals 4x minus 1. Now there is a couple catches to doing this. The first thing is this. If this is not greater than or equal to or less than or equal to, so for example, on this one you have y is greater than, on this one you have y is less than. Because there is no equal to sign, my line is going to be a dotted line. It's not going to be a solid line. If it was greater than or equal to or less than or equal to, then I would use a solid line. Okay, that's really the big difference between graphing the lines. So let's go ahead and let's graph y equals 4x minus 1. And I'm just going to graph this what I consider to be the easiest way. So we're going to start by graphing the y-intercept, which is at 0, negative 1. And now I'm going to use my slope. My slope is 4 over 1. Okay, so I'm going to use m1 to describe y1 and y2. So m1, the slope is 4, which means I'm going to use 4 over 1. For m2, my slope is negative 2, which means I'm going to use negative 2 over 1 to graph my points. So now I'm going to start here. I'm going to go up 4, 1, 2, 3, 4, right 1, put a point. And I'm going to do that same thing again. 1, 2, 3, 4, up, right 1, put a point. This gives me my first line. It is greater than, so this is going to be a dotted line. And let me, now I highly suggest using a ruler, because it will look a lot better. And I don't have a ruler to use, so there's not much I can do with that. You probably hear a little bit of background music. My wife's phone is actually going off right now. Alright, so now I'm going to go ahead and I'm going to graph the second equation. I'm going to do it the same way. So this time my y-intercept is at positive 3, so I'm going to go at 0, up 3, which is right here. And now I'm going to use my slope, which is down to right 1. Put my lines, 1 right there. Okay. And now I've got 3 points again, so I'm going to go ahead and graph my line. And again, it's a dotted line. See, this is not very easy. Let's see if I can fix that. Okay, and obviously the graph will look a little bit like this. Now I want you guys to make sure you're using rulers when you do this. I do not want you doing it just freehand like I'm having to do it right now. Okay, now here's where the catch is. Okay, so this is the one big difference we've seen so far is instead of this being a solid line, they're dotted lines because it's not greater than or equal to or less than or equal to. Now the other part is this. My values aren't just the lines. There are values above and or below the lines that also work. So you're going to use what we call the perpendicular line test. So y1 is greater than, okay, and this line right here was y greater than 4x minus 1, and this one down here is y less than negative 2x plus 3. And from here, we're going to have to shade the region. So for this graph, I'm going to use what we call the perpendicular line test. I'm going to draw a small perpendicular line. This is greater than, so I'm going to shade the side where the arrow is up. This is the side where my arrow is up, so I'm going to shade this region right here. And I'm going to draw these lines vertical for a reason. Okay? So now we're going to look at the next one, which is y less than. So I'm going to do a perpendicular line test here. And where the line is going down, because it's less than, this is where I'm going to shade. And I'm actually going to shade this one this way, I guess. Okay? And my answer then is the region, and this is where you have to be careful, okay? When you shade now, your answer should be the region in which both colors are present, which is going to be this region right here. And I'm just going to color it in with the green. Okay, and this is the answer to the problem. So when you're doing graphing of linear equations, you're looking at shading a region, and the region that both of them that are true for both. Okay, so if you look in this little spot right here, this little V, the region that's shaded actually would give us, if I pick the point up here, it would give us a true answer for y1. But it would not give us a true statement for y2. Same thing with down here in this little V right here. This would give us a true statement in y2, but not in y1. All the points here that are in the green are actually our answers because they will give us true statements for both y1 and y2. Okay? So let's go ahead and look at number 2. Again, we're going to put our x and y axis in. I'm going to do that right now. And this time, while I'm doing this, you should be able to, you should have recognized by now that the equations are not in slope-intercept form. So we're going to want to convert these to slope-intercept form quickly. Alright, so let's go ahead and we'll convert y2 first. So I'm going to just subtract 2x to both sides. And I'm going to get negative y greater than negative 2x plus 1. Now I'm going to divide by negative 1. And I get y is, remember, dividing or multiplying by a negative, you have to flip the sign. And this is going to be 2x minus 1. So this is going to be y2. y1 now, we're going to subtract 2x to both sides. And I'm going to get, let me actually put a little 1 here. I'm going to get y1 greater than or equal to negative 2x plus 8. And that's going to be in slope-intercept form. So now let's go ahead and graph our points. So I'm going to go up 8, 1, 2, 3, 4, 5, 6, 7, 8. And now I'm going to go down, my slope is negative 2, so I'm going to go down 2 and right 1. And I'll go down 2 and right 1 again. And that will give me the equation for this line. Let's go ahead and on this one, for y1, this is greater than or equal to, so this is going to be a solid line because it is greater than or equal to, which means I can pick values on the line and they will still give me true statements. So there's my first graph. Actually, let me erase that, make that a little bit smaller. There's my arrowhead. Here's another arrowhead. Alright, now let's go ahead and let's do the second one. We're starting at negative 0, -1. And I'm going to go up to right 1, which is right here, up to right 1, which is right here. Now this is going to be a dotted line because it is less than, it's not less than or equal to. So my graph would be roughly like this. And now we're going to go ahead and start by shading the regions. So the solid line is greater than or equal to, so I'm going to be shading this region right here. Now if you're able to do this without shading both regions, by all means, I personally think that's easier, but sometimes it gets confusing to students. So the other one, we're going to go this direction, and it's going to be less than, so we're looking at these values here. And now you can very clearly see our mixture section, which is going to be right here. And this is my shaded region, and that would give me my answer. So you guys make sure that this gets done, and work on the word problems if you didn't finish those already. Be ready to do some work on solving linear inequalities come Monday when you come into class, and I will see you guys then. Have a great weekend.